This is your first look at SolidWorks. In this brief demonstration, you'll see how Holmatro uses SolidWorks to design best-in-class tools to help rescuers perform their critical life-saving tasks. Looking at this hydraulic spreader, you can see that there's some work to do. We'll create a part, assemble several parts, and create some drawings. We'll start by designing a new rod end part to connect the piston rod to the spreader arms. The basic building block of a 3D solid model is a sketch, and sketching in SolidWorks is extremely easy and intuitive. Using a mouse gesture, I get access to my most commonly used commands. Draw a slot, add some dimensions to establish its size, and then drag the center of the slot onto the origin to locate it. Next, a rectangle is drawn using one of the many sketch tools, and then we will add a couple of circles to hold the link pins. The two circles should be the same size, so a quick window selection reveals a pop-up toolbar, and an equal constraint is added to lock their size together. Notice that as I work, all of the commands and tools are right at my cursor. We call this our heads-up user interface, which is designed to keep your focus on the screen to make you more productive. Now that this 2D sketch is finished, let's make it 3D by extruding it. It can be extruded in either direction, or in this case we will extrude it 40 millimeters, about the midplane. To smooth some of the sharp corners, we can add some fillets. Their size can be graphically manipulated on screen, or we can key in a dimension to add some precision. Let's add a pocket to the center of the part to accept some links. This time we will use a center point rectangle to capture symmetry while we sketch, and a dimension to control its size. Using instant 3D technology, we can add material by dragging the sketch away from the part, or remove material by dragging into the part. The sharp corners at the bottom of the pocket can be rounded by adding another fillet. 2 millimeters would be good. Finally, we can ease the outside corners with a chamfer. Using the on-screen feature callouts, we can easily control its size while we create it. Now that you have the hang of it, we will jump ahead a couple features and add a tapped hole at the bottom using the hole wizard. Gone are the days of looking up hole data, because all of the hole types, standards, and hole sizes are available. Choose the hole parameters, locate it, and SolidWorks takes care of adding all of the proper information to define the hole. Let's leverage our previously created chamfer by dragging and dropping it onto the bottom edge to make a copy. The part looks good, but maybe a couple of changes would help to refine it. Changing the dimension value changes the geometry, and using instant 3D technology, dimensions can be dragged and we get real-time feedback of our change. It's important that we fully describe our part beyond just the geometry. Properties such as part number or description can be added and leveraged later in the drawing title block and BOM. Materials can be applied from a list of favorites or from a broad database of materials. All visual and mechanical properties are applied. Notice that the weight of the part has been updated to reflect the new material. To document our design, let's create a drawing. SolidWorks displays the default views of the part in the View palette. We simply drag a view onto the sheet, then we can create any desired project views, including an isometric. Hidden lines can be removed or views can be displayed as shaded. For this part, it would be desirable to create a detailed view of the area near the bottom for clarity. Adding dimensions is simple. All of the dimensions that were used to create the part are available to be placed on the drawing. Since symmetry was used during design, we can add a couple dimensions to locate the round boss at the bottom. The Rapid Dimension Manipulator appears to properly place and space the dimensions at even intervals. Selecting a dimension, we are presented with a dimension palette where we can add more definition to the dimension, such as tolerancing or formatting. These 20 millimeter holes will not accept the 22 millimeter pins that we will be using. No problem. Making this change right here on the drawing will update all of the views and change the part as well. Let's move on to do some assembly work, and with SolidWorks, it couldn't be any easier. For our rod end, simply drag the round boss and drop it onto the cylinder rod. This adds a concentric assembly mate between the parts. To position it along the axis, we can drag the edge of the rod end to the end face of the cylinder rod to add a coincident mate. Next, we will add a link to stop it from rotating. To find this part, we will enter link in the search assistant. SolidWorks not only returns components with link in their file name, but also digs down into the part properties to find the term. As before, we can drag this link from the search pane and drop it on a circular edge of the arm to locate it. Then using the same drag to mate technique, we can hook it to our rod end. From the same search pane, we can assemble the pin. This pin was modeled for multiple uses and contains many sizes or configurations. We simply choose the diameter and length that is desired, and SolidWorks builds the part to specification. Most assemblies contain many hardware items like screws, nuts, washers, and the like. SolidWorks provides a toolbox of such items containing thousands of parts with millions of configurations of those parts for your use. Notice that as we assemble the snap ring, it automatically sizes itself to the shaft to which it is placed. SolidWorks allows us to copy parts along with their mates, which is a big time saver. Simply identify the hole and mating face for each hole where the pin is to be placed. As you can see, these pins are too long for the rod end. Remember, the pin was modeled in multiple sizes, so we can easily change the length of just these two without having to reassemble. Interference detection is an important aspect of 3D design, and SolidWorks takes it a step further with real-time collision detection. Notice that as we move the arm through its range of motion, it interferes with the link. SolidWorks provides both visual and audible feedback of the collision. A change is in order, and it can be done directly on the part right here in the assembly by changing the angle dimension defining the pocket on the arm. Now, as we recheck for collision, we can see that we have full range of motion with no interferences. Half of the spreader is complete, and we can save assembly time by mirroring the parts about the central plane to the opposite side. SolidWorks allows us to verify and change position of each part, and even to create opposite-hand versions of individual parts. In just 2 minutes, there were 19 parts added to this assembly, and our assembly task is complete. Let's turn on the parts that we have previously hidden and document this assembly. We'll wrap up the demonstration by creating an assembly drawing. As we did when creating the part drawing, we can drag the required views onto the sheet. To better describe this spreader, we will use an exploded view of the assembly. No assembly drawing is complete without a bill of material. SolidWorks itemizes the parts, extracts information like description, and adds the appropriate quantities. No bill of material is complete without balloons, and they can be added automatically. To depict the motion of the spreader assembly on a 2D drawing, we can add an alternate position view to describe the assembly in both the open and closed positions. Add a couple of reference dimensions, and our assembly drawing is complete. We strive to deliver simple but effective tools to help you design better products faster. When you have an idea for a great product, SolidWorks provides the tools to design it in less time and at lower cost. This has been your first look at SolidWorks. To learn more, contact your local SolidWorks reseller or explore our website for more information.